from here, from center to this point, WR50. If I can get by some equation, I can locate this point. And then total W50, if I know, I can locate the falling limb also. So this is WR50, this is W50. This is fifth point. Now, if I come to 75% of peak discharge, and if I know this distance, which is called WR75, distance of rising limb at 75% peak discharge from center, I can locate this point 6. And if I know W75, which is width at 75% discharge, this is 7th point. If I know these parameters, what I have written here, then I can mark these 7 points. And then what I do is, through these 7 points, I draw a smooth line. This will be my synthetic unit hydrogram. Clear?
Yes, sir.
So what I need now, these 7 points. I need these 7 points, or basically 1, 2, 3, 4, 5, 6, 7. If I know these 7 parameters, I can plot a hydrograph, which will be synthetic hydrograph. So for that purpose, the whole of the India, as I have told you, has been divided into 7 hydrometeorological zone, 1, 2, 3, 4, 5, 6, 7, then A, B, C, D, 20. And for every zone, there is a report which is known as flood estimation report, which is available on RDSO website, on CWC website. It is a joint work, minimum by these departments. Sometimes other departments are also co-opted: CWC, RDSO, IMD, MOST, and various others. Out of this 26, for 24 subzones, reports are available. For 2 subzones, there are no reports. And list of this we have seen in table 1 of RDSO report, or in that figure 2 of RDSO report, RBF 16. So in every report, first if you find the zone, and if you go to this report, you will find that a synthetic hydrograph equations are there for different subzones for design flood duration of 25, 50 and 100 years return period, pertaining to small and medium catchment areas. And as I told you, these are the 7 parameters: 1, 2, 3, 4, 5, 6, 7, and 1 hour. The TR, the rainfall duration, is 1 hour. Here rainfall duration taken is 1 hour. These reports are available, and how they look like is like this. This is, of course, I have told you the terminology: WR50, W50, WR75. This is TR, which is 1 centimeter rainfall and all. This is, we have already seen. And based on values of A, L, LC and S, that is catchment area properties. In some of the equations, LC is used, in subzones LC is not used, but these 3 are used in everywhere, and there are equations like this. Like, let us say, for an example, if you take Kaveri zone 3I, it will have 7 equations: 1, 2, 3, 4, 5, 6, 7. TP based on L, LC into S, then QP based on TP, then W50, W75, WR50, WR75, and TP. And TM will be TP plus TR by 2, and QP will be small qp into A. So basically 7 basic equations are there, and other 2 are derived equation. These equations are given for every subzone. So you will find out in which subzone you belong, and then you will use that equation and derive these values. Once you derive these values, then you will plot a unit SUH, synthetic unit hydrograph, for that area. Of course, there is a refinement and all, we'll see, but basically this is the principle how synthetic unit hydrograph is developed. Clear?
Yes, sir.
So now we will start solving an example. 5-10 minutes are there, we'll solve. Balance we'll cover tomorrow. Tomorrow afternoon, original, of course, tomorrow morning I have got classes, 2 hours. Afternoon, there was a lecture by VL, डायरेक्टर DMRC, अभी उसी का फोन था, प्रमित का. So he is out of Delhi. So tomorrow afternoon lecture will be day after tomorrow morning lecture, and day after tomorrow morning lecture will be tomorrow afternoon. In any case, I was supposed to be available in both, so that's the change. Previously, tomorrow afternoon was successful case histories of project management, DMRC, how they do things differently and all. Tomorrow afternoon 2 hours, and day after tomorrow morning my lecture. Now because he is out of station, he will not be able to make it back to Delhi tomorrow. So his lecture has been put on Wednesday morning, and my Wednesday morning 9 o'clock lecture will be tomorrow afternoon after lunch. Okay, so let us see this example for estimation of Q50 using synthetic unit hydrogram. So first of all, we have to calculate S. First thing. So here, this data, if you remember, this is the same data which we have taken from catchment area properties, and this too, reduced level. These two data we have taken from there. This X was distance from farthest point to bridge. If you want distance from bridge, then L minus this. So this is a calculated value. Length of segment will be this value minus this, this minus this, this minus this, this minus this, like that. So you can calculate length of segment. Then height of bridge from this. So this is reduced level of bridge. Now every value you have to deduct from this bridge location. So you will get this is height of bridge, DI. This is called as DI. Then DI plus 1 plus DI. So this and this, this and this, this and this. You will keep on adding. Then Li multiplied by DI plus 1 plus DI. So Li is this column multiplied by this. You will get these values and then their summation. And the formula given is this. Summation Li into Di plus I divided by L square. So from previous table you got summation Li. Units you have to be careful. Sometime in some of the reports it is given in feet and mile, so you have to convert it. And in our case 1180 point this, L was 23.257 if you remember, and with this you get value of S equal to, I will note down this, we will be using it further, 2.813 meter per kilometer. Same thing, I will just show you. Parallelly, I will open that spreadsheet also for you, so that, yeah, this is for Betwa. For every zone, this spreadsheet has been prepared. First is its cover. It says how this is calculated and all, and there is a link for downloading the concerned CWC flood estimation report also, in what is available on IRISN website. Here I have not put that link because we have got separately. Then it says what is, and then it says what you must keep. You must keep A for graph size, pencil, eraser, calculator. And then in this spreadsheet, this is logged only wherever this blue, this sort of thing is there, that is editable data. You can put it there. Otherwise, there are formulas. So next is input data. Now bridge number, whatever is available, kilometer, location we have written. Section is Jhansi Manikpur, Jhansi division. North Central Railway, Zone 1C, tributary is Burma. We can see from OSM and all. These were our latitude and longitude value corrected. Topography, if you want to write something. These were the topo sheets numbers. They are basically DM numbers I put because we are solved by GIS. Then this is part 1. Physiographic parameters. Catchment area. How much is the catchment area? So we had calculated 162.080. L. So you have to put only in this blue colored cells only. All other are automatically. Here, this is the data, 11 segments, and this is the distance what we have measured. Then this in kilometer unit, if it is different, you can correct it here. These are the reduced levels. So you have to give only these 3 columns. That's all. Balance all other calculation, it will do automatically. Then it will calculate this also. And now it was in some other unit, had it been in feet or mile, for that purpose. Longest length stream here, if it was different, you would have given that. Then you calculate equivalent slope, let us say had it been in foot and mile, like the original CWC report, it is in feet and mile incidentally. So this will come feet per mile, S automatically comes, and then you convert it by whatever factor. and get S. Equivalent stream slope, which is 2.183. So in this spreadsheet, it takes only few minutes, not more than that, and you will be able to calculate this. Now next is for this particular zone, these are the equations. These are the equations given. First, it is given QP in this form. Here LC is not used, only L and S and A are used. So based on this, you calculate QP, then TP, then W50, W75, WR50, WR75 and TB. All these calculations you have done. TM is TM plus TP plus TR by 2, 5.5 hours, and QP into a distance. So same thing in this Excel sheet for everything. These equations are written here and formula is fed here. So it will automatically calculate these things to you. Don't have to do these calculations. That is one. Now another thing which I want to tell here is many times this TB, your hydrograph will be plotted for base width duration TB. In this case TB is 19, it is manageable. But some of the zone like 2, I remember North Brahmaputra and South Brahmaputra, it was coming 126 hours. Now manually, I have done all these examples manually also, using graph sheets and all, then did them by QGIS, all this 22, 23, whatever reports available. Manually, number one, first you have to mark 126 points. Of course, then you will put your whatever synthetic unit hydrograph using 7 point. Then there is a process called verification, whether SUH has been plotted correctly or not. We'll see how it is. For that, you need ordinate at every place. Now reading this ordinate at every place and correcting it and all for 126 will take around 5-6 days. It is very difficult. So there, manually when you do, what you do is this TR, which is otherwise 1, you can take, let us say in this case, I took TR equal to 6 hours. If you do this divided by 6, then you have to put data for 21 points only and check it for. So that's why in manual calculation, many times we are required to take TR value more than 1 also. But when you do by spreadsheet and the method which I'm going to tell you probably tomorrow, no problem, you can take by 1 also. So that's why this is TR. If you want to take TR differently also, it is possible to take it. But in this case, I have taken as 1. And with that, it has calculated TM, TB and all other things. And then using this 7 equations, you will plot then SUH. Then you have to verify whether SUH has been plotted correctly. That also, one is manually how you do it. Secondly, by using IT tools, how you can do it. Now today time is over. So tomorrow, 11 o'clock, 11:15 rather, I will tell you how it is done. And we will conclude this example and start next thing. So up to here, what we have seen in medium catchment area, up to there we have come, and how to plot initial SUS, synthetic unit hydrograph. Its verification and then applying design storm over this and calculating Q50. That's a small portion left over, which we will do tomorrow. Yes, so if there are any questions on this, please ask before we close for the day. Any questions, any doubts? Yes, no.